We're going to look at question 3a from exercise 4a. So we're still in the hyperbolas chapter. Now, sometimes hyperbolas are written in this form, okay? And you have to do a bit of work on it, or just one step of work to show the left-right transformation. Because if I have 1 divided by 3x plus 6, I can't say the graph has moved 6 to the left, okay? Because automatically you go 6 to the left. Now, to reveal the true left-right transformation, so that's all correct, the true left-right transformation, whenever you have a number in front of the x, you need to take it out as a factor. Okay, so if I take 3 out as a factor, I get 3x plus 2. And you can see that the real left-right transformation is that the graph has moved to the right, okay? So unless you do this step, you can't, draw the graph properly. So what they've said here is they want you to draw the graph of that, and obviously draw the graph of the normal one. Okay, so the normal one will be 1 on 3x. So that's essentially the graph. The graph hasn't moved left or right, so you've got x equals 0, y equals 0, y and x-axis. So we've got asymptotes at x equals 0, y equals 0. 1 on 3x would just be a graph that's been dilated, so you don't need to really worry about what dilation does. You just draw the correct shape, which is like this and like this. So that's y equals 1 on 3x. Now, because I don't have any x and y intercepts, you need to choose 2 points. So first point, you sub in easy values. So sub in x equals 1 maybe. So x equals 1, y equals, I sub into the original, which is this one, 1 over 3. And when second point, when x equals 2, y equals 2/3. Okay, so when you're at 1, you're at 1/3. So 1/3. And the second point would be 2/3. And the reason why we do this is because we want to show what the dilation factor is. Because how can I tell the difference between this graph and the y equals x graph? Okay, because when you draw that, the base case, we draw the base case. I'm drawing it roughly here. When x equals 1, y equals 1, and when x equals 2, y equals half, so 2.5. Can you see that there's a difference between this graph and that graph? And the only way we can show the difference is by the 2 points, all right? Because there's a rationale behind having 2 points there. Now, for the other graph, remember we changed the equation to y equals 3x plus 2. So the graph has moved 2 to the left. So my asymptote is at x equals -2. Move 2 to the left. My y asymptote is still the same, so y equals 0. That's my x, that's my y. And I'm going to draw, it's going to be positive, so I'm going to have part of the graph here, part of the graph down there. So I'm expecting a, I'll draw this the shape properly. Remember how I was focused on your shape? I've got to make sure that it's roughly correct, okay? So let's figure out what the value is. So y-intercept, x equals 0, because I'm expecting a y-intercept. So there'll be 1 on 6, okay? When x equals 0, y equals 1 on 6, because that goes to, because the number goes to 0, the x term goes to 0, so you got 1 on 6 left. So that's 1 6. Oops. 1 6. I don't know what's playing up, but by hand somehow. Okay, so that's 1 6 over here, and you need a second point, okay? So the second point is, so that's y-intercept, second point. Choose x equals 1, because it's easier to sub in. So when x equals 1, you get 1 over y equals 1 over 9, because when you sub it in, x equals 1, that becomes 1 divided by 3 plus 6, which is 9. Okay, so 1 a ninth. Okay, I've got my 2 points. I've got my asymptotes. That's going to be sufficient to get full marks for that question. Okay, so just make sure you have everything labeled properly and everything drawn. Okay, and make sure your shape is okay. Right, this is probably not a good shape, but it's hard to draw properly on the computer screen. Okay, so use a ruler for your asymptotes, and you should be okay. Hopefully that helps.